All right, I think we're live. Okay, greetings everyone. Happy Friday. I hope everyone's doing well. I'm doing live stream for math tutoring. So anybody out there watching that has a question about their math, you're welcome to post it in the chat. And in the meantime, I'm just hanging out and I'll spend some time working on my board as usual. And yeah, so I'll go ahead and get into it. I hope everyone's doing well. And yeah, I'm still working on systems of linear equations. However, I did spend some time on this 4 by 4 matrix. It's a system of linear equations with 4 different unknowns. And I will admit, I did spend some time, my spare time, I did not get the solution yet. I think I got pretty close. But yeah, so I'm going to go ahead and erase my board and just try one more time to solve this system using the Gauss-Jordan elimination method. So just want to have that little minor caveat that I might not get this solved. And so we'll just see, see how it goes. I was trying to figure out how I could get the solution. And so I was remembering the method that I did before Gauss-Jordan of calculating the inverse, and I'm not sure how you would even determine the determinant of a 4 by 4 matrix. So I was kind of thinking about maybe trying to go through that method, but since I don't really, I'm trying to remember if I've ever calculated the determinant of a 4 by 4. Yeah, so it's really torn between, do I try to do the Gauss-Jordan method or do I try to calculate the determinant? And I think what I'm going to do is I'm just going to try to do Gauss-Jordan one more time here. And if I'm not able to solve this through Gauss-Jordan, I'm going to spend the weekend trying to figure out how to do the method of using the inverse, the method that I did before this one. So yeah, we'll go ahead and start. I've got this system. I don't know what the solution is. I could possibly put this solution in my I could put this matrix in my calculator and have it quickly give me the inverse. And I think we could solve it pretty quick that way. Let's go ahead and do that. Okay, just so we have the solution, but eventually I want to be able to do this. So, all right, let's go ahead and construct the augmented matrix like we did before. And yeah, making sure I wrote it down correctly. I think I did. I left my book in the other room. Of course I did. I'm prepared on a Friday. I love it. Okay, so it's summer, and so a lot of people aren't thinking about math during the summer, including me, I guess. All right, so we'll go ahead and construct our augmented matrix, just listing our coefficients and our constants and being careful making sure the rows are lined up. So we'll start out with 3, 6. There's no y in this one, so we're going to have a placeholder, 0, -3, and 3. And I'll just start talking informally while I'm writing these. My brain sometimes will not relent when it goes to work on something. And so I know that I'm not getting a whole lot of viewership just because I think that people probably don't want to see a method repeated ad nauseum. But I mean, I don't really have a whole lot of viewership right now anyway. So it's like I get to kind of take advantage of that and just I'm up here growing and learning every day and getting more comfortable with the camera. So even in that regard, it's a win for me. So yeah, it's fine. So we got 1, 3, negative 1, negative 4, negative 12. We've got 1, negative 1, 0, 2, 8. So we have 2, negative 3, 0, 0, 8. We're going to draw a line right here because we're separating our coefficients and the constants. So, yeah. All right. What I'm going to do is I'm going to pause and really, I mean, I'm doing this live stream for students, and if I don't have any students, then it shouldn't be a big deal, and I should not pressure myself I'm not up here trying to perform in any way. I'm just hanging out on my board trying to gain a skill. So I have to kind of keep that in mind. It's because anytime you're doing something live and there's potential of other people watching you, it does put a certain level of pressure on you. I think it's just a human psychological thing. And so I'm having to deal with that too. And yeah, I feel like I feel growth because I'm not allowing that pressure to kind of dictate, if that makes any sense. So anyway, all right. So I'm gonna get my handy dandy calculator out. And really, I would like to do some videos on the calculator showing people how to use it because it's actually pretty easy. There's a matrix button on this first column. It's the first column, fourth row, second matrix. And we'll go ahead and say B. And you scroll over to edit and you just select one of these matrices. They're already listed in here, and we're going to list a 4 by 4 matrix, and then it automatically like pulls up like a matrix for you, and you just put your digits in there. All right, so once you have your matrix entered, then you can exit out and then you can go and recall that matrix. And you can give it the inverse. And then I forgot to do math fraction form. So you can actually, it'll give it to you automatically in decimals, but if you ask it to give you fractions, it will. All right, so here is the inverse of my matrix. And so if we said this was A, and you name a matrix, you name it with a capital letter. And that's typically matrix A. So A inverse is going to be saying 2 over 15, 0, 1/5, and 1/5. And I just need to list, since it's not, I'm having to scroll a lot, I'm just going to do the first 3 columns, scroll, and do the last column because that's too hard to keep scrolling like that too long. So it's 4 over 45. This one is really ugly. 0, 2 over 15. We got 22, 45, negative 1. And this is negative 19 divided by something, and then negative 1 over 45. 0, 7/15, and then I gotta scroll. This was -19/15, 7/15, 1/2, and then that last column was 1/5, -1/5, 2/5, and -1/5. All right, so what I'm going to do probably over the weekend is try to calculate this inverse by hand. And but this is, according to the calculator, and this is probably correct, this is the inverse of this 4x4 matrix here. And if you recall that method, recall the method of using the inverse to solve the matrix, all we have to do is multiply the constants here, this row, by the inverse. So we're just multiplying two matrices. So we're going to multiply a 4x4 by a 4x1. So when you do a 4x4 and you're going to multiply it by 4x1, you check these numbers match, and the resulting matrix will be these two. So those two numbers must match for it to be able to be multiplied, and then the resulting matrix would be the 4x1. So we're going to go ahead and list our constants here and multiply this matrix to figure out the solution. So it's 8, 8. Because I really, really want the solution after working on it for 2 days. But I also want to know how to do it. I think I'm trying to figure out which one I want to know more. Like, do I want to know the method of solving, or do I want to just get the answer? And I think I really want to have the skill and have the method involved. So when you're multiplying matrices, what you're doing is it's rows times columns. So it's this first row times this column, and then put the answer here. So it's going to be the dot product of the row and the column. So we're going to say row 1 times column 1, and that's 2/15 times 3 plus 0 times -12, and we'll use some parentheses here because it's going to be a lot. 0 times -12 plus 1/5 times 8 plus 1/5 times 8. All right, so this is going to be 2 times 3, which is 6/5, plus 0 plus 8/5 for that one, plus 8/5. And then that equals, so we got 6, 8, 8, so 16, and 6 more would be 24/5. I believe 16. Oh, 22. Rather. No, I'm going to get that wrong. So it's 16 plus 6 more is 22, not 24. Okay. Oh, I'm so tired. I don't know about you all, but it has been a long week. And also the time of day that you do the math matters. Everybody's different slightly, but I do math much better. Like in the morning, I can spit out those numbers upon rising out of bed in the morning. But as the day progresses, my ability diminishes. So sometimes I have to teach college classes at night, and those are real challenging for me. Everybody has their challenges. So All right, so this first value, row 1, column 1, is 22/5. We'll just put that here because that's our first solution. And then we've got row 2, column 1. So we've got row 2, column 1. So it's this row now times this column. And where are we going to put this? We'll put it right here. I guess we'll have room. So it's 4 divided by 45 times 3. We'll use some parentheses to keep track of our syntax. 4/45 times 3 plus 0 times -12 plus 2/5 times 8 plus -1/5 times 8. All right, so we've got 4 times 3 is 12/45. 0 times 12 is 0 plus 16/5 plus -8/5. And so plus a negative, the negative unfortunately always will win. So that'll just be a minus there. Okay, and then I'm gonna have to get a common denominator of 45 here. So let's just convert these really quick. 12/45, and then 5 times 9 is 45. So I gotta multiply 16 times 9. So that is 144/45 minus, so that'll be 8 times 9, which is 72/45. All right, so we'll add the positives and then subtract the negatives. We got 156 minus 72. So this is giving me 84/45. So that's going to go here for my second solution. 84/45. And divided by 45, math 1. Yeah, it reduces down to 28/15. So we're going to reduce this down to 28/15 and then switch this out. Perfect. All right. So now we're going to do, we got to do row 3, column 1. And I'm already running out of board space. Let's see if we can fit it in here. Row 3, column 1. So it's this third row now times the first column. All right. So we've got 45 times 3 plus -1 times, so it's -1 times -12 plus, it looks like -19 times 8, -19/15. Okay, it's a +8 plus 2/5 times 8. All right. So we got 22 times 3. I think that's 66. $66 divided by 45. Two negatives make a positive, so this will be plus 12. It's a negative and a positive, so there's only one negative. It will always win. And then you've got 19 times 8. is 152 over 15 for this one. And then we've got plus 16 fifths. And I am going to have to get a common denominator of 45. So let's convert this real quick. 66 divided by 45 plus, let's see, 12 times 45. Uh, 540 divided by 45. And then 15 times 3 is 45. So I've got a 3. So that's going to be minus 456 divided by 45 plus, let's see, 9 times 5 is 45, so 16 times 9. We've got plus 144 divided by 45. Perfect. All right, so we're going to add the positives first and then subtract the negative. So we've got 66 plus 540 plus 144. So that is 750. I'm going to put it here so I have room down here to do the row 4, column 1. So we've got 750 divided by 45. Okay. And that reduces down to 50 thirds. And we'll put that here. 50 thirds. And then we've got row 4, column 1 now. So we're going to do the last row times the this column, and then this will be the solution of this system. So this is one way of solving. And again, these systems are really, really in-depth. They're really complicated. The more variables, the more equations you introduce in the larger system, the math and the time. And again, these computers now that we have, these processors can, I mean, you can plug this into AI and it'll tell you the solution, but if we have somebody else doing all of our work for us all the time, then we lose the capability. So, okay, everybody's seen the Wall-E movie. Everybody's floating around and hovering around on, recliners, sipping things through straws, and then, you get shook up and you fall out of your seat and you forget how to walk. So that's the moral of the story: is don't let your tools become crutches. You want to be able to make sure that you're taking care of yourself that way and being capable. All right. So our row 4, column 1. And so we're going to do negative 1 over 45 times 3. Plus 0 times negative 12. Plus 7 15ths times 8. Plus negative 1/5 times 8. All right, so if my calculations are correct, drum roll please. All right, we've got negative 1 times 3 is negative 3 over 45 plus 0 plus 7 times 8 is 56 over 15 plus negative 8 over 5. All right, we're going to get a common denominator of 45 again. So this is negative 3 over 45. 56 times 3. 168 over 45. And then 8 times 9 is 72, and 72 over 45. All right, so we've got 168 minus 75. Okay, I'm getting 93. So it's going to be positive 93 over 45. So 93 divided by 5, perfect. So that should be that fourth solution. All right, and I don't think that reduces down, but we'll try. Yep, it does. It's 31 over 15. So let's go ahead and switch that out. And we want our fractions to be in reduced form. So 31 divided by 15. Ta-da! Okay, so I believe this is the solution. I'm going to go double check the one I worked today to at least see how close I got. And yeah, I'm hoping that I'll find another move on because I have to be objective with myself. Systems, and it's just like I sometimes my brain will go to work on something and I can't relent, so I'm having to like think outside of the box to stop the subject. But I'm going to sleep on it and enjoy the weekend. I'm going to actually try to recalculate this one using Gauss-Jordan elimination method, but we have our solution. I'm very excited. It's so W. So essentially this is how it works. So it's W, X, Y, and Z. So you have an ordered pair where you'd have, I did the alphabet in order. So it's going to be 22 fifths, 28 fifteenths, 50 thirds, and 31 fifteenths. All right, perfect. All right, so there's your solution. And at least that was, I got something accomplished. It almost took me 30 minutes. Yeah, we'll go ahead and stop there. Again, this was not Gauss-Jordan elimination. This was using inverse. So. All right. Okay, so we'll go ahead and stop there and call that good for Friday, since I don't have any other problems to work for today. And so, yeah, I'll go ahead and end there, and thank you for watching my videos. And yeah, I'll be back Monday, same time, same place. And yeah, I'll sign off. I'll say bye for now, and I will see everyone next time.